So, hello, Michael.
Hi.
So just to review where we are, we've just heard a very interesting keynote speech on expanding economic data, the power of data science, machine learning, and AI. And you spoke about how modern AI tools could be used to generate new economic measures, and also how economists might benchmark such tools and compare them to existing methods. So the purpose of this after talk is to explore some broader issues beyond the remit of your keynote talk. So with that in mind, I've prepared some questions that I thought it could be interesting to speak about. So maybe to begin, you've described yourself as a cautious optimist in some settings around this topic of AI and economic measurement. But maybe to look at the other side of the coin, a question might be, we know by now that AI is successful in many domains, including domains that we might not have expected it to be as successful as it turned out to be. But do you see any domains pertinent to economic measurement where you think AI will always struggle in its current architecture? And if so, how we would think about the human AI interface in those kinds of environments?
Yeah, so I think it's a good question. One of the things that I showed was that there are at least existing tools, and we know that these tools are accelerating in their capabilities at a rate that's kind of means that stuff that it might struggle with today, maybe it won't struggle with tomorrow. But there are definitely, if we take an LLM as an example, which I think is most people's starting point for AI nowadays, they are trained on large quantities of language, but there are specific aspects of language that I think economists and the domain that you and I have worked in is that of monetary policy makers. And I think the language used in those domains is, particularly within their own internal discussions, can be quite different to the language they might use publicly that might have been the sort of core of what people think of when they think of macroeconomists. So some of the results I showed were that, like, in a forecasting domain where people are really talking about what's driving a forecast, text mapping to understand like what's going on it is very difficult to do well. Will it always be the case? I doubt it. But if I think the lesson, at least today's lesson, and this may change next year, the year after, I would give is that if you're working in those domains, don't assume that an LLM that does pretty well at, interpreting a politician's speech can equally do well at interpreting an econometric forecaster in a central bank's discussion of why they got to a particular number, because it may not have as much domain-specific knowledge on that. But maybe the optimistic, I'm going to come back to being optimistic. The optimistic response is, if you're worried about that, you can always take things yourself and try to train them. So you can go to a BERT framework and take something that you can train on your own data that you have some measure of gold standard on. And there you're likely to be able to do a little bit better, or at least to understand why it's doing well and why it's not. But yeah, while I'm optimistic, I don't think these are perfect tools, and you should always be cautious about the potential problems. Absolutely.
Sure. So related to this idea that domain specificity might be a bottleneck for the performance of AI, what do you think the role is for local model building? Because my view is that one of the reasons the use of AI is increasing a lot in the last couple of years is because the technical ability you need to interact with these models has fallen so far that anybody basically can go interact with the chatbot. But if you're interacting with one of these pre-trained models via an API, you're using a model that somebody else has built. And I sort of feel there's a trade-off between encoding general knowledge in the way that Claude has it, and that's the limit of your model, versus sort of taking a model in-house, as it were, or in problem, in domain, and updating it, fine-tuning it, interacting with it. So to what extent do you think it is important for economists to take models and adapt them to their own environments?
Yeah, I think there are environments where that's super useful, and that's something we tried to do in some of the work that I showed in the talk. And I fully agree. If we take Claude Code is not the exact same as Claude LLM, right? You can have queries to the LLM, or you can just ask the Claude, which is using the same basic LLM structure, to help you with coding. And you could ask the Claude Code to help you write code that would then ask questions of the ChatGPT via an API, right? So there's no requirement that you have to work, with just one model, or you can't build your own. And you're absolutely right. The big thing is the lowered costs of getting really hands-on dirty with these tools. So I described in the talk the idea that these tools are a bit like a super responsive 24-hour-a-day research assistant who has this very broad knowledge. And, the way that you might be able to use one of those, like an RA, a human RA, is the same way you can use these. So you could say, look, I have an idea. I want to do a model that has these features. And I need to use it with this data, and I need you to access it and train it on this subset, and then do this, and maybe take some different slices of the. If you can articulate the sort of research design, we no longer as much have to worry about the specific syntactic programming of that. And I think in a way, that's, again, I'm going to try to be optimistic, that's in a way where we're putting more weight on the creativity of the researcher to think about these things, to recognize the limitations of one model, or to think about ways to advance them. And so, right now it's very easy to just ask an LLM to do something for you, like classify this. You can also ask Claude Code to write you a naive Bayes classifier. Mm-hmm. And put your own features in it. So I think right now where we are, most people are in the former camp. They're sort of very comfortable at saying, I could get the LLM to literally do this. But increasingly, I think people are using the sort of the LLM technology to help them write. And I've mentioned Claude, other LLMs are available. There are ways that they can just help you. And I always joke that the way they help you is a way that I used to do it myself, by going to Stack Overflow, finding a similar problem, copying the code, adapting it myself. It worked. Was it the most efficient? No. Was it fully integrated in a neat way? No. Would proper programmers look at my code and go, God, never let that guy near coding? Yes. Now you can still, once you have the idea, you can get some entity, the Claude Code or the other coder, to sort of prepare the code in a fully integrated way. And again, I think it puts more weight on the creative research question, which I think is a good thing.
But I guess what I was asking was maybe a more narrow question. So if we could formalize economic measurement in the sense of having the ability to attach a true label to a set of documents, I guess my own experience has been that zero-shot learning, by which I mean directly prompting LLM to categorize a document as belonging to, say, category A or category B, almost never outperforms a fine-tuned local model. And so in some of this sort of AI craze, at least my personal opinion, is that the benchmarking exercises that you were discussing in your talk, I mean, if people did them properly, I think they would learn that zero-shot learning is not the preferred technology. And I wondered whether you sort of agreed with that as a prior on most measurements.
Yeah, but it's a little bit of an unfair fight, because if you take like Roberta, which is a BERT-style model, and you take the sort of foundational version of that model and you zero-shot learn that, it does pretty terribly. Mm-hmm. But when you fine-tune it, even just a little bit, its performance becomes, like you say, pretty much up at the level of a lot of the LLMs. Now, the reason I say it's an unfair fight is because the nature of the LLM being so big as to make it all essentially impossible for you to fine-tune in that domain. The lesson I would take is not that LLMs are necessarily bad, but that actually the being the jack of all trades and therefore not being possible to be fine-tuned, you don't have to use them. You can get as good performance in this labeling exercise and in fact, one of the things I mentioned, and this was a surprise to me, even if you put, say, just like the document term matrix of a text, but you put it into a sort of non-linear model that you then fine-tune, you can get it to do out-of-sample prediction that's up at the same kind of level as the BERT models, which are these bidirectional transformer-type models with this big neural network underneath, and even in some cases as good as an LLM, which is, we know, millions and millions of parameters. So I think that's an important lesson. But I want to go back to something, which is, I still think that this idea that I was getting at, where it's for the researcher to make the choice as to which models to look at, is an important one. So one thing that slightly annoyed me is that, in one of our first papers, we used topic models. Now, we used LDA. It's an unsupervised probabilistic topic model. And we were interested in knowing, across different things, how much sort of time were different people allocating to those topics. It's a good tool for that. I have seen tons of papers subsequently that have used a topic model to then try to say something about sentiment. And that clearly makes no sense. There's nothing in the unsupervised model that says you're going to get a topic that's about raising rates or lowering rates. You might be lucky, but it's not designed for that. And so, there's still an onus on the researcher to think carefully about what is a fitting world that I should use for this particular question in this particular domain. If you have the gold standard of some kind of truth that you can get to, fine-tuning is possible. But a number of people came up to me at the end of the talk and said, what is gold standard? And I sort of said, well, in some cases we have it, in some cases we don't, and you have to do your own human audit. And then your gold standard might not be everybody's gold standard, right? So someone could come up and say, well, Michael, you've labeled that data and you say you now have a model that predicts it pretty well. I don't like your labels. So what I think is a good model, they think is a terrible model because it predicts well bad labels. So I still think that I want to go back to the bigger picture point, which is the onus is on the researcher to think about all of those issues. But I agree with your point that we shouldn't think that LLMs are just the dominant technology and they can't be surpassed. In fact, they can be surpassed by these fine-tuned models that we've shown in some work.
Okay. So maybe on a slightly different track, we've been speaking so far about environments where there is a known data set. In some sense, you're trying to map that known data set or observations in that known data set into some category like sentiment. There's been another idea in the last year or two that AI can be used to generate truly new data. So for example, work where you might not have a survey instrument for measuring beliefs in a particular environment. So rather than, say, use an LLM to take somebody's actual written response to a survey and map it into some categories, the LLM sort of becomes the survey respondent. Yeah. And I wondered what you thought about that type of application for the production of new data, where they're really, it's sort of a purely synthetic exercise in a sense. And what's your view on sort of creating new synthetic measures and what their role should be in empirical work?
Okay, this is the part of the video that I may in some future date ask to be removed because I've made a Burke of myself.
Means it'll be the interesting part.
Now, I'm a little bit skeptical of that. Now, not totally skeptical, because there are some really interesting exercises you can do where you want to understand the behavior of these models, and you do so through the vehicle of seeing how they respond to certain questions. Do I feel like they're a good, genuine representation of, say, current conditions or how actual firms might respond? I'm just more nervous about that. Like, what are we doing? We're saying that the history of data that these things have been trained on, then given this particular prompt, it spits out these words related to a forecast or whatever you're extracting from it. What am I learning deeply from that data set? I think it really is dependent on the research question. So, one of the things at this conference that's really beautiful is you get together some policymakers, a lot of researchers, a lot of national statistical agencies, and, data scientists and economists and everyone sort of merging around, would I feel comfortable if the ONS said, we've dealt with, we've decided that some of our labor survey data is just going to be generated by a large language model? I don't think I would. But I can see environments where they're useful. If you want to check how, for example, an exercise that we did that I talked a bit about today is to see how different prompts give different responses. But that's more about understanding the LLM rather than thinking the LLM is a valid generator of views that I should take seriously in the world. So, yeah, the reason I think I may end up looking about, maybe I'm wrong on this. Maybe these are a wonderful tool, in which case, a big thing I talked about during the talk was how AI is helping to level the playing field, and you no longer need the research budgets to have 20 RAs because, $20 a month and you've pretty good access to Claude Code RA. Maybe that will also be true of survey responses. Maybe you don't have to have 10K to get survey responses every month. You can just get your LLM to generate them. I think the jury is still out on that as a valid use.
Seems like what people really want is the mental model that people might use to take macro data inputs and produce some output about beliefs about economic conditions. And so it's unclear whether this mental model, I guess, is or isn't encoded here.
It's also unclear that we understand what those mental models are. So this is why I realized that maybe LLMs have built a number of different mental models just through looking at so much text in the past. But, one other area that I work on is using surveys and incentivize sort of experimental survey environments to try to elicit what the mental models of different people are. And if you do that, there is a big heterogeneity in mental models. And I'm not sure how, like you say, I don't know which of those an LLM is drawing on.
And presumably they vary over time.
They vary over time. And I don't know to what extent telling the LLM to pretend like it has a PhD from LSE actually gets you like what you and I were trained in when we were at LSE. But also, when we were at LSE, we were trained by a certain subset of people. The people are now different. They'll have learned different things. What does it mean to be an LSE graduate? Like, I remain to be convinced on that side of things. Yeah.
Interesting. So you mentioned at some point during your talk that when you were first presenting empirical work that drew on what was then called machine learning tools, the younger generation was the one who was more, say, able to understand and appreciate the work that you did. So maybe turning back and doing the favor back to the younger generation, if you were a PhD student today, or even an undergraduate, it doesn't really matter, what kinds of skills do you think are the ones to focus on in this new world of AI augmented research? So what do you think is important to focus on? Do we still need sort of pen and paper solutions to DSGE models so you really understand how these things work? Or should we delegate some things fully to AI and just focus on questions rather than methods? How do you see this space?
No, I don't think you have to have as much of a revolution, at least in the economics part of the training. I should caveat this answer by saying, if you'd asked me 4 years ago, 3 years ago, what I would tell my kids would be a kind of a job, that a career, a degree path to career trajectory that would be sort of a good one for the future, I probably would have said computer programming via computer science. And that's kind of, we're not getting rid of all of them, but the number we need now are just being, reduced massively. So, again, going back to the answers I gave already, I think all of these great tools don't take away from the need to have creative questions, a clear understanding of why you're asking it, what channels you're trying to explore, and an understanding of all of the classical econometric issues of endogeneity, sample selection, etc. So in that sense, we don't have to change it. The example I always give to my own students, talking to macros people, is like, I'm old enough to remember when, if you wanted to solve a DSGE model, you had to write the model down, do all the first order conditions, get all your equations down, and then hand log linearize them, and then take those log linearized versions, put them into a vector representation, and then you could start to interact with something like Fortran or MATLAB that would work with those imposed matrices. And then actually Harold Uhlig had this toolkit that came along, and it was like, wow, that's amazing. And then Dynair came along, and that's really like, you just type your equations in and it will do all of the rest of the work for you. I still teach students in graduate economics how to log linearize and how the solution methods work. But I'm fully cognizant of the fact that beyond problem sets that we set for them, they will never actually do that. But I still think it's important they understand how.
Sure.
And to that extent, I still think we should teach our graduate students a bit about coding structure. But just knowing the exact syntactic commands in every language has just become much less important. You know, you work in R, I work in Stata. That's fine. I can take all of your R code and just pop it into Claude and say, this is R code that works with this data here and is trying to do the things in the R code. What would the Stata code for this look like? It will take it no time at all to do that. And again, yes, you should check and compare, but it's pretty good at those things. But we shouldn't change our education away from those things. Again, it puts more emphasis on the researcher's ability to identify the question and think about careful ways to answer it. I don't think that's changing.
Right. I mean, I guess detecting the mistakes that your RA does require you having done the coursework yourself at some point. And if you viewed AI as just a research assistant, I guess to verify its output still requires you to have done whatever learning it has done on its training data at some point.
And I don't want to make this mapping exactly equivalent, but to look at something like Dynair, again, you know, did Dynair mean that, you know, Cristiano and Eichenbaum, who sort of like wrote lots of papers with DSG models in the old world as well, did they stop writing papers or did they just get overtaken? No. They wrote more papers and better papers because this technology they could leverage. Did we also see, maybe this is the wrong language for a video, did you also see a lot of crap? Yeah, because anybody could just plug in equations and get impulse responses with no understanding of why they were getting them, what the mechanisms were, whether it was a good solution, whether there was determinacy issues that had sort of snuck through or what. So, yeah, the tool, let's not blame the tool. The problem is the researcher not really knowing what they're doing. And I think, again, AI is obviously far more broad and capable in all of its forms than just something like Dynair. In fact, I think if you went to AI and asked it to do all of that for you, it could do it as well. But don't blame the tool, right? It's the worker who needs to understand how the tool could be best deployed, and that doesn't change just with that. And so, again, my optimism, there's a pessimism. We are going to see more papers generated, and some papers, I mean, I'm sure you've seen them as well. There are people who basically just said, this is a question, this is where there's some data, can you knock me up a 20-page paper on this? And it does it, and the words all look kind of coherent, but if you dig into it, they're I think a lot of them are rubbish. And so, yeah, there's still a role for biological intelligence as well as the artificial stuff that you can leverage.
Okay. Well, thank you, Michael. I think you've been speaking an hour and a half or 2 hours straight now, once you include the keynote. And lunch, I believe, is waiting downstairs. So perhaps we can wrap up.
Excellent.
Thank you again.
Oh, good. Thank you.